Greetings. We are going to just look at some basics about what kind of graph a quadratic equation makes, and then we'll go into more details, but this one is just going to be just some rough ideas. So we know the whole ax squared plus bx plus c, or we should. That's our standard form. So when it's graphed, this quadratic equation creates a U-shaped curve that's called a parabola. All right, friends, so now we're going to look at something, and we're not using a graphing calculator, and so I can show you that technology, but will you learn to use this by hand? Do this by hand, but I have done a little more work already so that I know about where these parabolas will be. But a couple general things that we want to know is that if the a, so if the number in front of x squared, if the coefficient of the x squared, which means if it's just x squared, that's a 1, if this is positive, if a is positive, then the parabola will open up like a smile, all right? And in this case, this parabola is going to be like similar to that. Like, again, very rough. This is just a very rough. If it has a negative a, so when the x squared is negative, then it's going to open down like a frown. So kind of like this one. So when it's negative, the parabola opens down like a frown. So those are a couple just very rough things, that it has kind of that U shape, and if the x squared is positive, I know it's going to open up, and if the x squared is negative, I know it's going to open down. And more to come about other things, but sometimes, like if you were just looking at multiple choice, that information alone gives us a starting point. So kind of like thinking of when I know that the slope is positive, I know it goes up from left to right. If I know the slope is negative, I know the line, when it was a straight line, is going down from left to right. So this just gives us very basic information, and we'll see what else we're going to be able to figure out. So to actually make those graphs, I at least got an idea of where the turning point of the graph is, which is called the vertex. And to get there, I also found the axis of symmetry. And I wasn't very careful about how I sketched those, so it probably didn't look like it had an axis of symmetry. But the axis of symmetry is a vertical line that divides the parabola into two mirror images. If when you were a kid you ever created Valentines with hearts and you folded paper in half and then you cut your heart and then you opened it up, and your heart may not have been perfect, but the two sides were mirror images of each other. It was symmetrical, symmetry. So that fold would have been the axis of symmetry. There's a formula for the axis of symmetry. That formula is that x equal, remember it is a vertical line, x equal negative b over 2a. Not a coincidence, that looks like part of the quadratic formula. So if we have an equation, that is actually where we're going to start to be able to graph it if we have a quadratic equation in standard form. We can start graphing it by using the formula for axis of symmetry. That axis of symmetry tells me that dotted line that would divide the parabola into two mirror images. The vertex is the turning point of the parabola. So it might be things are getting smaller and then it turns and then it starts getting larger. Or it may be that it starts small and then it's getting larger and then it turns and starts getting smaller. So think about whether it's going up or it's going down. There is a turning point, right, where it changes direction. And that point is the parabola's vertex. When the vertex is a lowest point, it's called a minimum. And when the vertex is a highest point, it's called a maximum. So I'm going to go through and find some axis of symmetries and some vertex. The sketching, I don't even like to try to make the sketch until I have more information, because I'm just kind of picky about, I want my sketch to be good, and obviously my just rough views are, as you can already see, not good. Alright, so for this example, if we have the equation x squared plus 8x plus 15, that all equal to y, if I want to know the axis of symmetry, remember we're doing x equal negative b over 2a. So the b in this is 8, so negative 8 over 2 times 1. So that's negative 8 over 2, which means my axis of symmetry, negative 8 divided by 2, x equal negative 4. The axis of symmetry always goes through the vertex. So if I know this is my axis of symmetry, I know my vertex is going to be somewhere on that, and then both sides are going to match. So to find out where that vertex is, well, the x of that point, the vertex is a point, it says turning point, it is a point, so it has an x and a y. To find the y of the point, we're going to plug in this x to the original equation. So the y will be equal to negative 4 squared plus 8 times negative 4 plus 15. Remember that a negative squared does turn into a positive. So I've got 16 minus 32 plus 15. And I could type that all in my calculator at once, or I could, work it out on paper. But I should end up with y is equal to negative 1. So then the vertex is negative 4, negative 1. The x of the vertex will always be the same as the axis of symmetry. Then you plug that number in to find the vertex. So then that tells me where to start. So a very rough sketch would be that I have a x and y axis. Negative 4, negative 1 would be here. And then I know that this is going up. I know that this is my axis of symmetry that would divide it in half. I usually make that a dotted line. And then this one is going up, and this side is going up. Now, we're going to talk about making more points so that we know precisely where the points are, and if that parabola is more fat or skinny, how quickly it's rising, all right? But that gives us some basic information about the parabola. Okay, I'm not going to ask that you do sketches on these, but I do want us to have a little bit of practice on just finding the axis of symmetry and the vertex. And then maybe just tell me, does it open up or down? So that's what I'm going to model now. And then in the next lesson, we will actually make decently accurate graphs. All right? So here, axis of symmetry, remember x equal negative b over 2 times a. So in this case, negative 4, or hello, rewind. Of course, I actually have my recording going. Oh, pardon me. Negative 8 over 2 times 4, which 2 times 4, right? 2 times 4 in this case is 8. So then x is equal to negative 1. You cannot just write negative 1 because the axis of symmetry is a vertical line, so it's going to be the equation of a vertical line because it's a line. The vertex is a point. As soon as I have that part done, I know that that point begins with negative 1. So I got something going on. Now I'm going to plug that negative 1 in. I'm finding y, so y equal, I plug in this same number, negative 1, for both x's in the equation. Now, when you do this, if you're doing it out by paper, you're typing it in, whatever, but of course remember that squaring a negative makes a positive, and that the squaring happens before the multiplication. Exponents happen before multiplication, order of operations, right? So this becomes 4 times 1, and then I could go ahead and do some of this if I want. Negative 8 minus 1. So then I've got 4, subtract 8, subtract 1. So my y here is at negative 5. And I know this would open up because the a is positive. So extremely rough. I know negative 1, negative 5 is about here, and it's opening up. Alright, let's look at number 6. We've got like a big number there that usually kind of wigs people out a little bit. They see big numbers and we're all worried. So x equal negative b over 2a. So negative b here, the opposite of negative 24, positive 24. And then we're doing 2 times negative 3. So remember, this is like opposite of negative 24. That's how that becomes positive 24. 2 times negative 3 for my 2a is negative 6, which makes that negative 4. So x is equal to negative 4. It will not always be a negative, just happens that that's what I've chosen there. And then to find the vertex, we're doing negative 3 times negative 4 squared minus 24, you'll want your calculator handy, times negative 4 minus 42. So the numbers look like, oh my goodness, they are going to be so big. It doesn't turn out to be nearly as big as you fear. So negative 4 squared, positive 16, negative 3 times positive 16, negative 48. Also, for some of you, you may want to just type all that in the calculator, as long as you're typing it in right. Negative 24 times negative 4 makes positive 96, and then we also have a negative 42. Now, if I'm doing this in my head instead of the calculator, personally, I put those two negatives together first and then only subtract once. So if I add those two negatives, I get negative 90, and then 96 minus 90, y is 6. So it looked like it was going to be super big, but the positives and negatives kind of balance out, and it's not nearly as big as we might have thought. And so my vertex would be at -4, +6, and we know that this would open down because I see that my my x squared term, has a negative coefficient. So on the next page, as far as the homework assignment, what I would like you to do is just fill in things from the notes. So do number 1 through 5, and then if you would do just 6 through 9, only find the axis of symmetry and the vertex. So you don't need to keep going past that. Just do the front page. Don't worry about the sketch. And then in the next lesson, we're going to go beyond that and actually make a reasonable graph. Thanks.